Hi everyone. Today I'm going to share some results from the thermal walks that I've conducted uh, in Singapore through my association with School in Singapore project. So my name is Yuliya. I'm currently a postdoc at School in Singapore project at Singapore Management University. So the motivations for the studies are to better understand the individual exposure, which was currently highlighted in previous research. And also, we know that just thermal sensation vote scale, perceptual scale might be not enough to understand how uncomfortable or comfortable people are feeling. So also to understand their differences between the scales and explore how thermal pleasure, alesthesia, can occur in urban environments. So basically, there are quite a few studies that look at more controlled environments, but I was interested how can we achieve this thermal pleasure in a city, and also. I decided to use the method of thermal walk in order to do that. And another motivation for the study was to conduct it in Singapore. It's a tropical environment, so I think majority of the studies are done in conditions with uh, sunny days, mostly cloudless days. But in Singapore, it's quite difficult to achieve those conditions. So also the motivation was to understand differences in responses in thermal perceptions on hot days, but kind of different weather conditions. So my research questions are in regarding that: how does outdoor thermal comfort vary rapidly over space and during different weather conditions? And also, how does alesthesia occur and vary in different urban spaces? And also whether and how that influences individual health. So the methodology was thermal walk. As I mentioned, we used Singaporean Marti card developed by Aryan Midal to measure microclimate. Then we used survey tool to track thermal perceptions, as well as wearable devices. Fitbits equipped with also eye buttons to measure skin and wrist near the wrist temperature that we borrowed from Climate Resilient Cities Lab from UNSW. So this is briefly the methodology or data analysis process. So I have the weather data, then demographic data from the participant, including their age, gender, height, weight, clothing. All that was used to calculate specific PET per this participant. So all this data, calculated PET in Python, gender, age, specific PET for participant, and then also we collected heart rate and skin wrist temperature, and basically the data from Smarter was merged with data from the sensors by the location. So then we can have an approximation of how a person would feel while they walk on a transect. And they walked two different transect, one in downtown Singapore. This is the first transect, so you can see that there were 10 different stops on the route where they would stop and answer questions. And the stops differed in their urban morphology, presence of vegetation, and also differed in sky view factor along those stops. And some stops were exposed to sun, the orange ones, and others were in the shade. And then the second transect was done in the park. So here you can see, and some residential area, nearby residential area next to the park. And basically, again, you can see that stops differ in their morphology, presence of vegetation, but there are, of course, more trees. Then here is just briefly the descriptive of weather conditions. And I just want you to pay attention that the mean air temperature was quite similar for all the days. And also mean radiant temperature was quite similar, but there was this one day where relative humidity was higher compared to the other days. This was for downtown, and then for park transects, as well. Mean air temperature was similar for both days, but one day their humidity was higher on one day. So here, this is just PT for participant. We can see that it's generally maximum PT is higher, but the means are also similar. So now, if we look at the basically differences of PET per stop for both downtown and PET transit, we can. I ran the ANOVA model. It showed significant differences between the stops, and there were more significant pairs in the downtown transit. I just want you to pay attention on this stop too, because you can see that PT was higher on the first 2 days, but then it was lower on the last day. It was sun exposed, but the last day there was just a cloud over it. And here I looked at bin PET versus MTSV vote, and you can see that there was quite a good R square in relation to their thermal sensations and PET. But what caught my attention was this stop 2. It looks like the PT was really high, but they didn't feel as hot as I would expect them to. So then I looked on their thermal comfort, and indeed I found that people felt more comfortable even though PT was higher, and this goes back to that stop with high with high PT that I showed before. So I think that's possible because it was in this environment near the trees. They were in the sun, but they could see trees actually. And also it was just at the beginning of the walk, so thermal history plays a role. And this is the results for the park. So the neutral PET for the park is slightly higher than a neutral PET for the urban transit. Here is 31, and here is 32. Actually, it was the same for both days. So I think it shows that people can tolerate higher temperatures in the park versus urban environment. And finally, I wanted to look the potential of alesthesia. So this is the result for the urban transit. And basically, you can see on the top panel shows the pleasure votes, mean pleasure votes per stop and per previous segment. So previous segment is in lighter shade and stop is a darker shade. And then the second panel shows the PET. And then I only looked at the differences in their votes and differences in PET between the stop and previously walked segment. And I found strong relationships in this. So basically, you can see that for about 5-degree change in PET, we can achieve about 1-degree change in pleasure votes. And this is not an absolute temperature, right? So we're only looking at differences in PET. And similarly for the park transit as well, I have a strong relationship between differences in pleasure and PET votes. And also, if you look here, like even though mean PET was similar, but this day the humidity was higher and the MRT was lower, and overall pleasure votes are higher. So I think this helps also answering the question whether high humidity or like what's more uncomfortable, high humidity or high MRT. So this shows that people are still tolerating higher humidity better versus high MRT. And finally, I just wanted to show some results from what I was looking at influences on health. So here you can see just the correlation for heart rate, skin temperature, and near the wrist temperature, and they are correlated with all the environmental variables. And there is the correlation with PT is lower than compared to, so there is pretty high correlation with air temperature and the mean radiant temperature, and lower one with PT. And then near the wrist temperature and skin temperature, they are correlated. So I think that has potential for developing models on how we can approximate skin temperature from near the wrist temperature from using wearables. And Finally, I looked at the relationship between skin and near the wrist temperature. I'm still working through this to understand exactly what is the relationship, but what we see here that there is a clear pattern on every day. And so we can see that the environment definitely affects their wrist and near the wrist and skin temperature. And also that maximums for both wrist and skin temperature were higher in the urban environment compared to the park environment. Furthermore, I calculated the heart rate in the upper 20% zone for each participant. So I just took their, I calculated heart rate based on their age, like the maximum heart rate, and then I looked at the upper 20%. And I found that their heart rate in the upper 20% zone occurred almost 3 times more often in the urban environment versus the park. And also it occurred for more participants. So I think it indicates the positive effect of the park on health. And in conclusion, I found that the method of thermal walk is effective in understanding pedestrian thermal comfort and participants' sense of pleasure, they were highly sensitive to changes in PT. And basically that there was a higher thermal tolerance in the park. They were willing to tolerate higher temperatures, PT temperatures in the park. And basically this tells us that we don't need to aim to make all places, PT in all places, neutral and comfortable, but with careful planning on how to create those differences in spaces, we can achieve thermal pleasure and design cities for thermal pleasure. Yes, that's it. Thank you so much.
Are there questions?